Hello everyone, please welcome our next and final speaker for today, Kent C. Dodds. He is software engineer, educator, Google developer expert, also speaker, teacher, trainer with deep involvement in the open source community. Kent is creator of epicweb.dev, epicreact.dev, and testingjavascript.com. Also known as an instructor on platforms like egghead.io and Frontend Masters. Let's hear his talk. Caching for cache.
Hello, JavaScript FW days. I am Kent C. Dodds, and I'm going to talk about caching for cache. So you can take a look at kentcdodds.com to learn a little bit about me. The biggest thing I want you to know is that I'm working on epicweb.dev, where I want to teach everything I know about building epic web applications to you. So give that a look. And let's go ahead and get into this. This talk is going to be a deep dive on caching fundamentals, and there will be some code examples. This is not going to be comprehensive. There's just way too much to discuss in the half-hour time that I have today. And so there's going to be a fair bit of kind of hand-waviness over some of the complications of caching, but the idea is to get a pretty good solid understanding of what caching is and lots of the problems and challenges that you face when you want to start caching. So let's get started. There are two ways to make your app code faster, to make your application have a better user experience because it's faster. The first way is to delete your code. You could delete it will run very fast. If there's no code to run, that runs crazy fast. Or you could just reduce the amount of stuff your code is doing. So just get rid of the pieces of the code that is going on. And there are like optimizations you can make, and reducing the amount of stuff your code is doing can mean a lot of things. So let's talk about some of these ways to make things faster. First, deleting it. I don't know about you, but I enjoy my job. I like making money so I can eat, and so don't take my job from me. We can't delete it most of the time. Sometimes we can, but most of the time we can't just delete our product. We need to have a job. So let's talk about reducing the stuff that our code is doing. Most of the time, that's almost everything that we're doing. There comes a point where you can't just reduce all of the things that the code does until you ultimately delete it all. So we can't always reduce it, but it is really important that I want to emphasize these points first before I get into talking about caching, because caching is pretty significantly challenging and brings a lot of problems. And so if you don't first ask yourselves the questions of deleting and reducing, then you could be implementing caching unnecessarily. I talk about this more in my talk and my blog post, Don't Solve Problems, Eliminate Them. So you can give that a read, and I also gave a talk with that title, talking about how if we take a couple steps back, we can go down a different direction and have fewer problems and completely eliminate some of the problems we invented with our first solution. So that's one really good thing to consider. And then also, I have another blog post about React specifically, titled Fix the Slow Render Before You Fix the Re-Render. And this is just about the fact that if you go ahead and say, well, no, let's use the react.memo to make sure that this thing doesn't re-render unnecessarily. Well, if it's slow because it just is slow, reducing the number of times it re-renders isn't really going to solve that problem. It's the same sort of thing when we're talking about caching. So let's first eliminate problems. You can delete a bunch of code, then you can reduce the things that it's doing. But if you can't delete it, you can't reduce it, you can't just make it faster because this piece belongs to another team you don't have any control over or whatever, for whatever reason, then yeah, we're going to cache it. But not this kind of cache it. No, sadly, we're going to cache it, which brings a whole bunch of interesting challenges. But solves a lot of problems too. So let's talk about caching it in this way. What is caching? Well, Wikipedia says in computing, okay, there's tons of words. I'm not going to read that to you. No thanks. Let's look at an example instead. So I've got this function here called compute pi, which computes pi out to 10 decimal places. And if I wanted to cache this, because this is a relatively slow operation, then what I would do is I would make a variable called pi, and then I'd make a function called compute pi cached, And if pi has not been assigned yet, then I will call compute pi and assign it to pi. And now I can return pi. And so in the future, when somebody calls compute pi cached, they will not have to call the heavy function compute pi. This is caching. It's actually very similar to the singleton pattern, if you're familiar with that. That's it. This is what caching is. So caching is storing the result of a computation. So you store the result of a computation somewhere and return that stored value instead of recomputing it again. That's what caching is. That's the whole idea behind caching. And so that was the simplest example of a cache, but most of the time our caches aren't quite that simple. So let's add a little bit of complexity. What if we had an option for precision? So you can specify how many decimal places you want to compute pi out to. Well, now we've got a couple other things that our function can do. How do we cache that? It is going to return more than just one possible result. It could return many different possible results. So with that added complexity, increases the complexity of our cache. Now the pi cache is not just a variable that we assign, it's an object that stores the computed values. And we check the type of the pi cache at that precision, so whatever that value is. So at precision 1, it will have one value, precision 2, it will have another. And so if it's not been computed yet, then it will be undefined. And then we can assign that value to the computed version and then return that value. So yeah, that actually works out pretty well, but it introduces a new concept in caching that I want to talk about that can be really complicated, and that is the key. So that precision is what we call a cache key, and that just identifies the value or maps the value to the cache. So when we're going to look up what the value is, we need to have this key to identify the particular value that we're looking for. So let's talk about this key a little bit. And we'll use another example that is a little bit more, well, the function itself, a sum function, is very simple, but the cache is going to take multiple arguments, and so we got to think about that a little bit. So here we're specifically assigning the key is the string a comma b. So that will be, if we call sum cache here at the bottom line 14, 1 comma 2, then the key is going to be 1 comma 2. And so the first time we call this, that is going to be undefined because our sum cache is an empty object. And so we compute the sum. It's not really a heavy function. We're just using this for illustrative purposes, but we call that sum function, assign it to that value in the cache. And then the next time we call sum cached, we're going to compute that same key. The key will look exactly the same, 1 comma 2. And then when we do the type of check, that actually does exist in our cache. And so we'll skip over that if statement and just return the value. So let's actually watch this in progress. So I have a debugger. I'm going to dive into the sum cached. I compute the key, which is now 1 comma 2. I check the cache for that key. It doesn't exist, so we actually compute the sum, which ultimately results to us returning the value of 3. And then and now our key is 1 comma 2. When we go into the next call, we're going to compute that same key because we pass the same arguments, and our sum cache has a value for 1 comma 2, and that value is 3. So we step over the if statement, and now we can just return what the value is in the sum cache. That's how caching works. That is the idea behind caching. You have just some place where you store the value, and then you compare or you check the cache first before you do the computation. So there are a couple of interesting implications here. Let's first talk about the problem with keys. So I want you to play a little game with me. We've got this add days function where you can provide the number of days, and then we compute some time into the future from today. So we create a new date from that number of days into the future. And so we want to cache this for various reasons. So we decided to make an add days cached. We have a key that is very specific to the inputs that we're receiving, but there's a very big bug in this, and I want you to think about that for a second. Where could the bug be in this implementation? Well, the bug is right there on the key. The problem is, what happens if I call this today and then wait 24 hours and call it again tomorrow? So the first thing will be, yep, there you are, Homer. I'm so sorry. The first day will be a cache miss. So we actually do the computation. The second time we call it will be a cache hit because it's already in the cache. That'll be 3 days from today. That's fine. But then if we wait 24 hours, we add days cached 3. That's a cache hit. It'll be 3 days from yesterday, which would be 2 days from today. So we're in trouble. This is not doing what we need it to. This is a bug. And the reason that this bug exists in this code is because of this very important fact. Cache keys must always account for all inputs required to determine the result. If they don't, then you end up with bugs like this. And here's why this can be quite a significant problem with caching. It's easy to miss an input. Really, really easy to miss an input. In our case, the input would have to, like our key would have to include date.now because that's what we're using to perform our computation. That makes the cache completely useless. A cache is only useful if you actually are going to access the cached values. If you never access a key again, well then what is it even doing? You're never going to get a cache hit. So if you never get a cache hit, you probably shouldn't have a cache. So yeah, easy to miss an input, especially if you're like making changes to the code and then you forget, you miss out on some input. Another problem is too many inputs, and we'll look at an example of that. And then computing the correct cache keys can be costly sometimes. That alliteration is intentional. Computing correct cache keys is costly. So let's look at each one of these really quick. It's easy to miss an input. Here's a good example of this. Any of you who've been doing React for the last couple of years have probably had trouble with dependency arrays. useMemo is a caching function, and you have to list all of your inputs in that dependency array. That's not super fun. There are linting plugins for ESLint that will help you avoid missing inputs. And the fact that that has to exist is pretty illustrative of the fact that that is a problem. So it's easy to miss an input. Sorry, especially when you're making changes to existing code. The second one, too many inputs. Here's a good example. This is a screenshot from Google Flights from Salt Lake to Amsterdam. And yeah, if we look at all of the different options for these flights, there are basically an infinite number of permutations of all of these filters. The number of stops you want, the airlines you want to use, the bags that the number of bags you have, the price, the times, the emissions, the connecting airports, the duration. There are so many things, and each one of these has like multiple options. And so there are just so many different permutations of this. Also, of course, the destination, the origin, the date, whether it's a round trip, number of people, what class it is. Like you combine all of these things, and it's just like no way could you cache all of this stuff very efficiently. So you very rarely would end up getting cache hits because there are just so many inputs. So this is a problem. I don't have any insider knowledge on Google Flights, so maybe they do have some level of caching for some things, but caching the entire results, probably not. That wouldn't make too much sense. And then computing correct cache key is costly. So for my personal website, I use GitHub as my CMS, and I store Markdown files or MDX files for all my blog posts. To generate the blog post page, I have to download the GitHub or download the MDX file contents from GitHub. And then I compile that MDX into code that I can then evaluate. Of course, that's going to take too long for every single user, so I need to cache that. But the cache key for the compiled version of my blog post, the only reasonable cache key would be the contents of the blog post itself. But to be able to get the contents of the blog post, I have to download that all of that code from GitHub, which doing that is just too costly. There's no chance that I could actually do that without I can't do. I couldn't even say, okay, well, we'll take the slug. That is our cache key for the download, because how do I know when I make an update to my blog post? So there's not any cache key that can actually identify or go from slug to compiled post. There's just no way to do this. So there are some situations where caching or including all of our inputs into the results just are not possible. So we cheat. We have to be okay with giving the user something that's potentially stale, something that doesn't include all of the inputs. But this is just really, really good for you to acknowledge when you're doing this sort of thing because you are cheating. And it can lead to problems if you don't acknowledge that and embrace that. So let's talk about cache revalidation to kind of sidestep some of these issues because we have to cache it. There's just no way we can't cache some of this stuff. So how do we handle this sort of problem? We revalidate the cache, and we can do it a couple different ways. So you can proactively update the cache. So when I update a post, I automatically update the cache. I have a GitHub CI job that will say, based on the commit that was just pushed, were there any content changes? Oh, yes, there were. Then let's go tell this, the running server, hey, there were content changes here. And then the server can proactively go and fetch from GitHub to update things. It takes about 5 seconds from the time I push and deploy to getting the action running and getting the cache updated. I don't even have to do a deploy if I haven't changed any source code. If I'm just updating the content, then I just have to do this cache revalidation, and it works. It works really well. So you have to intentionally and proactively update the cache. The challenge with this is if there are a lot of different things that can update the value or the inputs to your cache value, then that can be really difficult. It'd be kind of easy to miss. Oh yeah, we changed the user's name over here too, so now we have to update the cache for this. That can get kind of messy, but that's one way to address cache revalidation. Another is timed invalidation, and a perfect example of this is cache control headers. So when the browser talks to a server, the server can send back a bunch of headers, and one of those is called cache control, where it can specify what we call directives. And one of those directives is max age, where you specify a number of seconds that the browser should hang on to that resource in its browser cache. So in the browser, it has its own cache, and it stores all of these resources by the URL. So it says, okay, here's the key. The key is the URL. You can actually control the key a little bit too with another header called vary. But we'll keep this easy. So it's just the URL that it's going to say, okay, this URL resulted in this resource, and the cache control header said, hang on to it for 60 seconds. So for a minute, if the user triggers the browser to make a request for that resource again, it will say, oh, you told me to hang on to that for 60 seconds. I'm not even going to talk to the server. I've got it in my own cache. So that's timed invalidation, where we're just waiting a certain amount of time before we go and update our cached version of that value. That works pretty well for a lot of use cases where you're okay with users seeing some stale stuff, but you're not always okay with that. And increasingly, our users are really interested in seeing like the latest up-to-date stuff. So speed your stuff up, folks. But sometimes you just can't. You got to make these trade-offs. Another option here is stale while revalidate. This basically is an extension on top of the cache control idea or the timed invalidation idea, where you say, okay, I want you to hang on to the cache for 60 seconds. But let's say that revalidating after that 60 seconds is over, that takes a long time. You don't want your users to have to wait for that length of time to get an updated value. So instead, what we'll do is we'll say we can consider it to be a valid value for 60 seconds, but then we have another 60 seconds or another 5 minutes where we're okay if the user makes a request in like an additional request for that resource in 2 minutes. We say, oh, well, that's a stale value, but they told me it's okay to give them a stale value. So I'll give them the stale value, but then I'm also in the background, I'm going to go say, hey, go give me an updated value. And so I can update my cache. So this is really cool because it means that users, they will get stale values, but at least they're never going to have to wait for the updated value to work. Some CDNs support this, and it's a really, really nice feature to have. You can also force a fresh value. So you just say intentionally, like on my website, when I'm signed in as the admin, I can add a query parameter called force, and it will just force all of the things on the page, all of the resources that are used on the page to revalidate their caches. So my blogs, my tickets for my workshops, my podcast episodes, stuff like that. That can be really, really useful, but there are a couple of problems with this that we'll talk about in a little bit. And then there's this feature called Soft Purge that Fastly, as far as I'm aware, the CDN Fastly is the one that kind of, I don't know if they came up with it, but that's the CDN that I'm aware of that is actively supporting this feature. And it's very, very cool. The idea is kind of expanding on our point number 3 with stale while revalidate is once the browser is like, oh, or the CDN says, oh, this is stale, but they said they're okay with serving something stale, so I'll go and revalidate it in the background and give them the stale thing. Soft Purge basically says, make everything stale, but make it okay to send the stale thing and revalidate. So this is another option that you have. The benefit of this is if you just delete things from the cache, now the user has to wait. The Soft Purge is really useful for when you're like, I'm okay, or I'd accept the trade-off of making the user see something stale over making them wait to get the latest up-to-date thing. We'll talk a little bit more about Soft Purge later as well. So those are a couple of the things about cache revalidation, but I want to talk a little bit, like a little bit of a side note about caching in like HTTP world and CDNs and stuff that we were talking about. So static site generation, SSG, is a really common thing. And it's effectively just build time caching, where you take the files, you build them, and then you put them up on a CDN with proper cache control headers. And that is your cache. That's effectively a cache of your source code. And every time you change your source code, you have to rebuild and update the cache, is what you're doing. It has absolutely, contrary to common belief, it has absolutely no performance benefits over a fully server rendered site with CDN and proper cache control headers as well. So there's no performance benefit. Now, it may be a little bit simpler from the development standpoint in some cases, but yeah, and those cases are increasingly becoming less and less relevant every day. But yeah, no performance benefits at all. And in fact, there are a lot of serious limitations. So I want to talk about my other side note. SSG also has severe limitations as your product evolves into dynamic requirements, which most products that we're building that we're actually paid for eventually will evolve into that. Even most of them start that way. But if you start with SSG, then you're forced to choose between re-architecting or offering a worse UX. So my recommendation is start with a fully rendered server. So there you go, my opinions on SSG, but I'm not your mom. You do what you want. It's fine. You're probably fine. Don't worry about it. But I will not use SSG for this reason, because it's just so severely limiting and it makes things really difficult in going forward in the future. You end up creating abstractions that are basically like a CDN with proper cache headers if you go with SSG. We call that ISR. There you go. That's all I have to say about that. So let's talk about another caching problem. So here's another example. We have this get video buffer, and reading that file, maybe it takes a long time. We're reading the file a lot, so we add a cache to it. So there's another bug here. I want you to find the bug with this one. What could possibly go wrong with this code? We're getting like, it's a pretty standard cache thing. The implementation of the function itself is not even all that complicated. It is async. We're returning a promise there, and so we're waiting. Like that all is fine. There's nothing wrong with that. The problem is right here, that object, video buffer cache. Most of the time, you do not want to do a cache as an object like this. Don't do it, because fatal error. You get a memory fail or out of memory error. So yeah, sorry again, Homer. Just had to do it. Yeah, you'll run out of memory because, like, let's say these videos are like really, really big. You read all those files, store them into memory, and you do read enough of those files, and pretty soon you run out of memory in your process. So cache size is definitely a consideration, and you almost never should you use an object for your cache, not like this. So what do you use? Instead, you can use the least recently used strategy, which actually can be implemented in various ways. But the idea is you just get rid of old stuff. So stuff you haven't accessed recently, get rid of it. This actually is extremely optimal. It's really, really simple, but it's extremely optimal for the fact that we can't tell what the future is going to hold. We don't know what people are going to ask for in the future. At least for a generic cache, maybe you can do something more specific to your use case. You're like, oh, once they access this, I'm pretty sure they're going to access this. So let's hang on to that one. But for a generic cache, this is 100% really, really common, very, very optimal. And the LRU cache that's implemented on NPM is phenomenal for this. And it's in memory and everything. And you can control how big you want your cache to get and everything. It's great. I use it. It's fantastic. Another option is to use the file system. So you can just put things in the temp directory. A lot of tools unofficially, but actually do put things in the node modules.cache directory. So your Babel and ESLint and various other tools kind of abuse the node modules directory because it's git ignored and you don't want to commit cached files. So it's pretty common to stick things in the .cache directory in node modules. I'm not saying whether it's a good idea or a bad idea. I'm just saying that's the idea that a lot of people do. But the idea in essence is your node process may not have a lot of memory, but your hard disk probably does have a lot more space. And so you just stick stuff in the hard disk and then you can read files out of it. Now that may not really help with our video buffer solution because that's what we were caching in the first place, but yeah, that's kind of the idea here. SQLite is another good option. It's just a file, but it's very, very fast because it's a local file. There's no connecting to an external database or anything. And you can even have this be distributed with LiteFS. And that's actually what I'm doing on my own personal website is I have a distributed SQLite database. And that's my cache. And then Redis is a super common solution for this. They like to brand themselves as more than just used for caches, but that's the thing they got really popular for because it's an in-memory database. It's super fast. Just want to point out that cache size can still get out of control. Even if you're using these things, you can run out of space. So just keep an eye on your cache size. Okay, let's talk about cache warming. So it's cool that you can get everything like stuck in a cache, so you don't have to make calls to third parties and stuff like that all the time. But yeah, what if your cache is empty when you're first getting it up and going? There's some big problems with this. You can get rate limited by APIs. So you're calling these APIs a million times, warming up your cache, getting things warmed up, yeah, that can be a problem. It definitely has been for my site, and I've had to find ways to work around that. Requires a lot of resources too. All of a sudden, you have to go and get the cache fresh for all of this stuff. This really only matters if you're like actually warming up the cache. You don't want users to have to warm up the cache because it's really slow or something. Yeah, if you don't do it efficiently, then it can require a ton of resources to get that all of the things that you are expecting people to need into the cache. Yeah, it makes users wait for those fresh values. So if the users are hitting you while you're warming up the cache, you haven't gotten it warmed up yet, then yeah, they're going to have to wait for it. So those are a couple problems. It turns a nice calm setting into just like a panic of like all of these things happening at once. Oh my gosh, we have to we're hitting these APIs, we're using these resources and all of this. So yeah, there can be problems with cache warming you just need to be aware of. So one of the solutions is a soft purge. So instead of just deleting all of your cache and then having to rebuild it from scratch, you can do a soft purge. And what that will effectively do is just say, the next time somebody hits this, go ahead and serve them the old thing and fix it up in the background for them. So that's one thing that you can use to improve this a bit. Just a warm up, don't go wild. Cache entry value validation. So what if you have some value in your cache and then you make a change that will result in that value being different? So that could be a major problem if all of your code is depending on this new value being available. So it's a good idea when you're reading things out of the cache to have some validation layer there, because especially if it's persisted, that's an IO boundary to your application. So it's a good idea to validate anyway. This is just another quick one that you should think about. cache request deduplication. So if everybody comes in to grab some value, you're selling a new product and everybody's coming in, they want it all at the same time. If you're not deduplicating the requests, then you could, as cool as it is that you have it cached and it's going to be really fast, you are sending like 1 million requests, and each one of those is going to be cached when it's done, but that is not going to result in a very happy customer base. So you'll want to make sure that once the first request goes out, the rest of the requests are waiting for that one to get cached before they proceed. This is actually kind of like data loader, if you've heard of that, that kind of deduplicates a bunch of requests for the same resources. And the last thing I want to really talk about here is Cashified. So when I was building my website, I did a lot of caching stuff. And so I didn't build Cashified. I kind of did. Inside of my code base, I built this utility function that implemented a lot of these things. And then this wonderful person decided, hey, how about we extract this into a library, which is exactly what I was hoping would happen. And they did a phenomenal job and added a bunch of really cool features, improved things. In fact, cache deduplication was not a thing that I had. They added that. And as well as soft purge, they just added that a couple days ago. So Cashified is awesome. If you're looking for fine-grained cache capabilities, take a look at Cashified. And that's about it. I have one more thing. Hey you, you're awesome. Thanks everybody. See you later.
Hello again. Thank you for a great presentation, and I'm really happy to have you with us at our conference. So let's start with some questions. And the first will be, of course, you mentioned a lot of caching tools, but what is your favorite one?
Oh, there are a lot of caching tools because there are a lot of use cases. And so a lot of these tools you need to use together for different situations. So for example, I do have some in-memory caching with LRU cache for things that I'm only going to cache for a short while, things that I'm okay with like having go away whenever the server needs to restart or something like that. For example, queries that take a couple of seconds to execute that I don't want to make the user wait for the result. But I also like it's just a couple seconds. And I can execute it like as many times as I like. So I'll cache that for like 60 seconds, and that works out pretty well. But then I have other things that I know don't change very often, and so I want, and on top of that, I have like rate limiting to consider and stuff like that. So I'll have persisted caches in SQLite. I used to do that in Redis, which is also a fine tool. And so, yeah, those are the two main cache or like server-side caching mechanism or tools that I'm using. And both of those are using that package Cashified that works really well. So I guess those are my three favorite tools for caching.
Yeah, sounds good. And also, another question. Imagine you have something like Google Flights, and you need to cache or store somewhere those filters. Like when you open the same page, next time it should be predefined all those filters. What would you use? Maybe SQLite or maybe local storage or whatever. What is
Yeah,
your option?
for that particular situation, I don't know what Google is actually doing, but I would be surprised if they actually have that cached at all, because there's just so many permutations. There may be some aspects of it that are cached. So like they may have whatever API they're using to talk to the flight, to get what the flights are, they might have that cached. And then they may have a couple other smaller, lower level pieces cached. But the higher up the abstraction you go, the more variables feed into that. Like even time will feed into that. Especially things like price and things that's going to change on a regular basis. And so Maybe they've got caching for some of the lower level things. Even if it's just 60 seconds, it can speed things up for people quite a bit. But yeah, so like the most important thing that I want people to come away from this talk is that caching is not your solution; it's your workaround. And you should be focused on making things fast. And then only when you've exhausted all things at your disposal should you worry about making it cached.
Yeah, thanks. And as you mentioned also during your presentation, use memo. Is it more about caching or memoization? Like, what
Yeah,
is
that's a good
correct?
question. Yeah, so memoization is a form of caching. It is, in fact, that's exactly what memoization is. The idea behind memoization is that when you have a function that returns the same output for a given input, then it can be memoized, which is just cached. You take the inputs as the cache key, and the output as the cache value, and that's it. So that example of the sum function where I had the sum cached, that's basically a memoization function. So yeah, use memo is 100% a cache. There's a little bit extra with use memo because it's associated to a particular element or React component. And so if you have one component that uses use memo and then you render it in two places, each one of those will have its own individual cache. And then on top of that, use memo's cache is a size of 1. And so as soon as there's a new value to be computed, all the old values go away, and it's just going to keep the new one. And that dependency array, that's your key. And so anytime any of those change, it's going to recompute the new value, throw away the old one, and just keep that new one around. So yeah, it is a form of a cache, just pretty lightweight.
Okay, thanks. And let's check some questions from Discord. If we use RTK query, it's cached every request by default. But do we need to cache everything? For example, if we have table with bunch of filters and we cache every request, it becomes problematic to know when you need to invalidate all this. So to know when we don't need the cache also.
Yeah, that's
Good
a great
question.
question. And this is why I emphasize so much that it's important to focus on making things fast, and only when you've exhausted all your speed requirement or abilities do you bring in caching. Having cache as a default is probably it's probably fine, sort of, for something like React toolkit or Redux toolkit query or React query, just because a lot of the users of those tools are pretty limited with regard to what they can do about their backend. Like they can't just go make their backend faster or something. But really, the solution is to make your backend fast so that it can respond to user interactions and things really quickly. But yeah, invalidation is a major problem with this. And what you end up with when you cache heavily, even if you do something with the stale while revalidate, well, you end up with two problems. One, you end up with stale data, which I think is what is being talked about here. And then the second is if you use stale while revalidate, then you end up having the user go to a page and they have the old stuff, and then the new stuff pops in place, which is like, okay, that's kind of neat, but it's a bad user experience. A user would probably rather wait 50 milliseconds or however long it takes to get the real data, and rather than see a flash of stale data. And so as far as like by principle, I say having cache for every request as a default is probably not the best. Um, and so, yeah, how to know whether you need the cache? I think um, you should start without the caching as the default, and then add caching when it becomes obvious you can't speed it up any further, and you need it to be faster.
Yeah, thanks. And probably the last question before we jump into Discord. Will AI replace the developers? Not related to your topic, Martin.
Yeah. I did say ask me anything.
Yes.
I hope not. I hope that AI can continue to improve in its role as a developer assistant. That's kind of the way that I am using it right now. I use AI assisted development constantly. That's my primary mode of development, is using AI to help. And there's a lot of gaps still where AI could help even more than it is right now. Um, Maybe eventually AI gets good enough that it can do all of the things that I can do. At which point, hopefully, the world is a wonderful place, and everybody just shares in the wealth of that AI is creating for us, and we can all just do whatever we want. That you know, you know, hope maybe that's the way it will be in the future, but based on what goes on in the world right now, I kind of doubt that. So, yeah,
Yeah,
my
could
hope
be.
is that we can all, like, as a world, take advantage of AI to make everybody's lives better, not just those at the top. I'm pretty confident that uh, our jobs are safe for quite a while, and I can't think of anything else that you would do to prepare for such an enormous change in the landscape, other than just keeping an eye on AI and using it as an assistant to your work today. Just stay up with what it can do for you.
Yeah, yes. Thanks a lot. So let's jump into Discord channel or video channel, Discord voice channel, video channel. And please, we can continue to talk to candidates. And of course, we'd like to say thanks a lot for a great presentation. And let's meet in Discord.
Okay, thank you. See ya.